Hello guys, welcome to my channel, The Consistent Coder. Hope you're doing great. So the problem that we are going to solve today is unique paths. Let's see what the problem is about. There is a robot on an M by N grid. The robot is initially located at top left corner and you want to reach the bottom right corner. The robot can only move either down or right at any point in given time. We are given two integers m and m. Return the possible unique paths that the robot can take to reach the bottom right corner. So the problem says that we are given an m by n value representing the size of the grid. So here m is 3, that means we have 3 rows, and equal to 7, that means we have 7 columns, and then we have to return how many different ways can be reached to the finish given that we are starting from the top left corner, right? So we have to return total number of different ways. So let's take an example and see how we can solve this. So the question is basically asking that we start at the top left corner and then we wanted to reach the bottom right corner, and then it is asking how many different ways can we actually reach here. So we have to understand two important things in the question that I mentioned. At any given cell, right, if we are on the starting point, there are only two different ways we can move. One is towards the right and the other one is towards the bottom side. You cannot move diagonally, you cannot move up, you cannot move left. So these moves are not allowed. There are only two moves that are allowed, that is right and then there is bottom, right? Following that logic, let's say I'm on the end, right? So if I'm on the end, from where could I have come to this end? There are only two possibilities. One is this cell. I could have taken a bottom direction, and from this cell I could have taken a right direction to reach the end. Could have come from this cell to the end? No, because this means that I'm moving diagonally, which is not allowed. So this move is not possible in order to reach the end. So what does it suggest me? What does it tell me that I can only reach the end from this cell and this cell? This says that if I know how many different ways I can actually reach this particular cell, let's say that is A, and if I know the number of ways I could have reached this cell, let's say B, so the total number of ways I could have reached the cell E, the finished cell, is going to be A plus B. Right. Let's see with a simple example if that is actually the case. What I'm saying is that now if I'm starting here, let's say this is my end cell now. Forget that this is the last cell, because it will be easier to actually see what I'm telling about if we take a smaller kind of grid. So the grid that I'm now considering is this. So this is the grid, simple 2 by 2 grid. Okay. So this is the 2 by 2 grid that I'm considering actually. So forget about the rest of the grid. So now I'm saying that in order to reach the E, I could have either come from here, one cell above and the one cell to the left of it, right? So if I know this is A, this is B, so that means in order to reach the end cell, there are A plus B different unique paths. So let's see if that is actually the case. Now I know that what is B actually here. So B actually represents the number of ways I could have reached this particular cell, right? So what is that? From starting, I can only reach to this particular cell in one way. There is no other way. I could not come from here, right? Because that is not possible, left side, or I could not come from this cell to this cell. That is also not possible. There is only two different directions that we are allowed, right? To the right or to the bottom. So from starting, if I take a to the right kind of direction, I'll reach to this particular cell. So B is actually 1. So following the similar logic, A is also 1, because I can only reach from starting to this cell in only one direction. There is only one path that I could have taken to reach this particular cell, right? So now I know A is 1 and then B is 1. So that means that I could have reached my particular this end cell from the starting in two different ways, because A plus B is 2 here. Let's see if that is actually the true. If I'm traveling from the starting to the end here, what are the different paths that I could have taken? So one path is this, right? And the other path is this. Could I have taken, any other path, the diagonal path or something? No, there are only two paths here. So the logic is actually solid. So following that logic, how can we solve this problem? So the logic is that if I'm on a particular cell, I could get the total number of ways I could reach the cell by calculating the sum of the different ways I could have reached the cell to the one that is immediately above and the one to the immediately to the left of it. So the number of ways I could reach the end point is going to be A plus B, where A is this and then B is this. So now in order to calculate this, I need to know how many different ways I could have gone here, right? So that would be sum of this plus this. So basically I need to know how many different ways I could have come from here, and then if I sum it up, I'll get this particular value A. So this is a recursive kind of pattern that we are observing, and it's kind of hard to see if we are coming from the back side, but if you're coming from the front side, it's kind of easier to observe and easier to maintain. Let's see what I'm talking about here. So I'm at the starting point, right? How many different ways could I have reached here? Now we have already seen this, it's going to be one. So there is only one way that I would have reached here, which is towards the right. Now how many ways could I have reached here? It's still one. Remember, we are not counting the total number of steps. So if you are counting the number of steps, you might get confused. We are only looking at number of ways we could reach here. So there is only one way I could reach here, which is going to be this way, right? From the starting, I could only reach this way. So that is what I'm talking about. So for this entire row, it's going to be one, because there is only one way I could have reached any of this cell from the starting, because this is one way. I could not have come to this particular cell in any other possible way, right? So there is only one way. And similarly, the bottom direction also for this entire particular row, it's going to be one, because there is no other way I could have reached this particular cell apart from coming directly from the starting, directly bottom to the directly below to the start, right? So this is one way and this is also one way. Now let's fill up the other cells. Now what does this cell represents? This cell represents the number of ways. This cell represents the number of ways I could have reached from here plus number of ways I could have reached from here. So it's basically 1 plus 1, which is going to be 2, right? So this is going to be 2. And what about this? This is also suggests that I could have either come from here or I could have come from here. So this will give me 3. And what about this? So this is 1 plus 3, which is going to be 4. And similarly, this is going to be 5, and this is going to be 6, and this is going to be 1 plus 2, which is 3, and this is going to be 6, and this is going to be 10, and this is going to be 15, and then this is going to be 21. So the number of ways that I could have reached to the end here for 3x6 grid is 21 different ways. Let's code this up. So first we need to define a grid, right? So we'll define a grid using the values that are given to us, which is m and n, right? So, and then we'll make sure that this particular grid is filled with zeros initially. So that way we can actually so initially we'll define a grid, right? So this grid will have m rows, and then it will have n columns, okay? And then it will have n columns, and then we'll fill everything with zeros initially. And then what is the next step that we are doing? We are trying to make the first row to be ones, because if we take any point in the first row, the number of ways I could have reached this cell is going to be 1, right? Similarly, for the first column, if I take any cell, the number of ways I could have reached there is only one way, right? We have seen why that is the case. So let's do that. So for let, we'll write a for loop, and then we'll just take the first column and then we'll make it zeros, and then similarly we'll do this for the first row as well. So we'll simply take the first row and then we'll make everything to be ones. And now what we are doing, and then we are calculating the rest of the different ways that we could do by using the recurse relation, which is going to be if I'm at the cell m comma n, then what am I doing? M represents the row and n represents the column. I'm adding the one value to the above of it and then one value to the left of it. So basically it is going to be, if I'm on the mth row, I'm doing m minus 1 comma n, whatever the value of this is, plus I'm doing the same row, but one column to the left of it. So the same row and one column to the left of it. So whatever the value that is at this position, whatever the value that is at position, I'm adding those. So I'll simply loop through it again, but I'll make sure to loop it from the index 1 because index 0 has already been handled. And now I'll simply loop through this entire thing again, and then for j equal to 1, j less than, we are looping through the column here. And then what will I do? And then for grid at I at j is going to be grid at I minus 1 at j plus grid at I and then j minus 1. And then finally what we'll do, we'll do grid at m minus 1 and then at n minus 1. Because we are following the 0th indices, we'll just have to simply do minus 1 at the end. Let's see if this is working. So as you can see, the normal case passed and then it got accepted as well. I hope you understood the problem, what it is talking about. And if you guys like the video, please give me a like, and I'll be uploading videos related to top interview questions and blind 75 regularly on a weekly basis. So please do consider subscribing. Have a great day.